In this lesson, we're going to go over changing some equations from exponential form to logarithmic form, and then going the other direction, logarithmic form to exponential form. Doing a few basic properties to get us started before in a couple videos on number 45. We'll really get into kind of the meat and potatoes of the logarithmic properties. Okay, so let's start in this first section, these first five, by going from an exponential equation to a logarithmic equation. Now you should know at this point in our work with logarithms that a logarithm is just an exponent. So when I rewrite this using log log, I'm going to choose the base of my exponential equation to be the base of my log. Then my argument is going to be after the equal sign, so that 32 is the argument. So log base 2 of 32 is going to be equal to the exponent of 5, right? Remember, the logarithm is always an exponent, so that's why equals should always be the exponent. Okay, next one. Log base 12 of 1 equals 0. We'll talk about why that's kind of important a little bit later in the video. Then we have log base 7 of 1/49 equals -2. That's just a reminder again, when you have a base raised to a negative exponent, we're going to have 1 over that 7 squared. This one I'm going to do 2 times, so watch this. Log base 10 of 1,000 equals 3. Now I'm not going to write that. I'm going to leave it there. But going forward, anytime you have a log with a base of 10, that's called a common logarithm. So kind of like in our days with the square root function, you don't have to put that index of 2 in there, right? It's assumed to be. Same thing here. If I just do a log of 1,000 equals 3, right there in that base is assumed to be a 10 unless you put something else. Okay, so it's called the common logarithm. So going forward, if you put log with no base, I know it's the base of 10. And last but not least, log base 5 of the square root of 5 equals 1/2. All right, so that's going from exponents, exponential equations to logarithmic equations. Let's go the other way. All right, now this way is a little bit different. I'm going to start at the base. I'm going to raise it to the exponent. Remember, logarithm, just an exponent, and equal it to my argument. So 4 to the third power is equal to 64. Okay, do the same thing for this one. 9 to the negative second power equals 1 over 81. And last but not least, 25 to the 1/2 power equals 5. Which makes sense because the 1/2 power, we should know at this point, just means take the square root. All right, so that's going the other direction, from logarithms to exponential equations. Okay, some basic stuff here from your days in algebra. Anything to the 0 power is 1. This is going to be 5. And remember, you write this as 1 over 5 to the positive first power, which is 1/5. All right, that's going to be helpful. Here's some basic properties of logs. Like I said, in 2 videos from now on notes 45, we're going to get into a lot of very, very specific logarithm properties and how to use them. But for this scenario, we'll just start basics. If you have a logarithm of any base and your argument is 1, that's always equal to 0. If you have a logarithm where the base and the argument are the same, that's always equal to 1. If you have a base and the argument is the same and then you have a power, that power is what that's going to be equal to. We'll talk in 2 videos about something called the power property, which will kind of show you that as well. This one's probably the most confusing. If you have a base and in the exponent is a logarithm with that same base, then whatever this argument is what the answer is going to be. And then finally, we'll use this more in the next video. But if you have a logarithm with the same base on each side, then each of these arguments have to be the same. So you can see we're going to drop the logarithms. And that's really the next lesson. Okay, so let's do some evaluating, and then we'll use some properties. Okay, so starting with this first one, the way I do this is I'm just going to write question mark. You can write X or whatever you want. So 3 to what power gives me 81? So 3 to what power equals 81? And that's going to be the 4th power. Right, so the log base 3 of 81 is 4. Same thing here. 4 to what power gives us 1/4? All right, we know for the first power, is 4. But because that 4 is now in the denominator, I'm going to write -1 to get that answer for that logarithm. The next one, 23 to what power gives me 1? And hopefully you know anything to the 0 power is going to be 1. All right, next one here. 36 to what power gives us 6? This one I'm probably the most confusing until you start to realize that if you're getting smaller but not fraction-wise, right? There's no fractions here. We are going to need to take the square root of 36 to get to 6. So that power is going to be the 1/2 power. And hopefully that's a reminder from the first semester or maybe earlier in this semester when I said you should really remember anything to the 1/2 power is the square root. Okay, this one is 10 to what power gives us, I'm going to write it as 1/100th, right? 10's hundredths place. All right, so 10 to the second power is 100, but because it's 1 over that, I'm going to write -2. Okay, next one here. 100 to what power gives us 10? Hopefully you see this is another square root situation, so that power is going to be 1/2. All right, almost done with this section. All right, now you hopefully remember from this one here that if the bases or the base and the argument are the same, that's equal to 1. So the base is the square root of 11, the argument is the square root of 11, so that's 1. And similar to the one after that, if this base is the same as the log base in your exponent, then this is just going to be equal to the argument 30. Again, we can prove that in class if you're having trouble with that one. Okay, so the common log here. So we have this, I already mentioned, base 10, right? So if you don't write the base, it's assumed to be a log of 10, right? So the log of 1,000 is going to be 10 to the third power is 1,000. And the log of 32, I don't actually know this one, right? It's 10 to what power gives us 32. It's going to be somewhere in between, right, 1 and 2. But I use a calculator to find that one. Okay, so last thing before we move on, let you guys practice the homework, is the natural logarithmic function, right? We talked about that letter E, or that number E, when we talked about graphing logarithmic and exponential functions. So if you want to write a logarithm with a base of E, we have a specific type of notation for that. We use ln, right, for our natural logarithm. So again, if I write ln of like 8, that's saying the log base E of 8, right? So that's what a natural log is. So in this first one here, right, there's a little tiny E there. So then that's just going to be 3. There's a little tiny E there. That's just going to be 1. No matter what the base is, if an argument is 1, that's 0. And then like before, this one I would actually have to use a calculator to find the natural log of 32. All right, so 2.78, that's roughly E to what power would give us 32, somewhere in like the 3 to 4 range. All right, guys, so that's it for this. Don't forget to try the homework and come see me if you have any questions.